Hi, this is the second part of the 1-1 videos. And what we just want to remind you real quick is our lesson essential question: how do graphs and equations reveal information about a relationship between two quantities? The previous video from Mrs. Gross went through lesson example 1 and example 2, so we're going to start right in with example 3.
So again, we're always thinking about going through the example and then the try it. So if you don't have your companion out, I would grab your companion. I would also grab your notes section. And we're talking about intervals that are positive. And so when we're thinking about this, we're thinking about a coordinate grid. And we remember that we have quadrant 1, 2, 3, and 4. And for some reason, we always use Roman numerals. Nice, but when we're up here, we're in above the x-axis. Both of these quadrants are positive. When we're down below, both of those quadrants are negative.
And so we're talking about where the graph is and what the value of the y values are.
So for this graph, looking at it, we know that it's a parabola. We know that it's shifted down 9, and we're going to talk more about that in problem 1, 2. But if you threw it into decimals, if you did a table and you graphed it out yourself, you would see a parabola that opens up, kind of looks like a smiley face, but we're looking at what intervals is the function negative. And so when we take a look here, we said down here was negative, so we're looking at from here all the way to there. And so we've kind of done some pre-thought, and now we can jump through this solution and see what our book is telling us. So
they'll provide you that graph even. So remember, f of x is just a fancy way to say y. So the y values are greater than 0. In other words, above the x-axis. And remember, it switches at wherever the graph hits the x-axis is where it switches, because it's negative down here, it's positive up here, it's 0 here. So 3 and -3 is where that graph was crossing through the x-axis. So that's where it changes from being negative to positive. So between here, the graph is below, and so that's why x is less than -3 and greater than 3.
That's where it's positive. And so when we go through and we're wondering where it's negative,
oh, sorry.
No, that's okay. We still got that same function idea, and we're looking at it in words. And so we're below the x-axis between the x-intercepts of -3 and 3. When we look here, you might think, well, that's an ordered pair, but it's not an ordered pair. It's the interval notation. Remember in the last video we talked about parentheses, because we're not including -3. We're not including -3 because, as Mrs. Conway said, that's 0. It's not positive, it's not negative. At this value, it is 0. So we have a parenthesis instead of a hard bracket and a parenthesis. So we're going from here all the way to here. And as we stated already, so we can move on. Is there anything else?
Nope.
Okay. I always want to check when we're working in Savas about these double bullets up here. So we want to go to that next one. Here's the try it for you to try in your companion. As I look straight at this, I'm recognizing that this is function notation, another way to think just y equals. And I'm thinking that this is linear. Anything else you want to think through on this one?
Nope. I would sketch a graph and then just ask yourself, where's the graph below, where's the graph above? And remember, we're trying to tell the x values where the y values are above or below.
So even though we're looking at the y values, our interval is going to be stating the x values.
So that try it should be written in your companion book. I think on page 2 is where that's at.
Mm-hmm. Now we're on to example 4. And so, thank you, Vanna. So as we're looking at it, if I was working through this, I might have my Canvas open on one page, I might be watching this video on another, and have a split screen going. But in this one, we're identifying where the function is increasing or decreasing.
So increasing, you just think uphill. Where is the graph going? Uphill. We always read from left to right. Decreasing is downhill. So positive is the location of the graph. Increasing, decreasing is the direction of the graph.
So for what values is x, of x is g of x equals 2 minus, the absolute value of x. We talked the other day about how this is going to be an absolute value function. Get rid of those arrows. And so we can see this V shape. It's very, very characteristic of an absolute value graph. You could throw it into decimals, but they have it here, so why would you do that? When we're increasing, we're looking at
what x values is the graph going uphill? So don't worry about the arrows on the end. You're always reading from left to right, just like a book. So the graph is going uphill when the x values are everywhere from, well, we assume this keeps going, so negative infinity until the x value is 0. So negative infinity to 0, that interval notation again. And then decreasing is downhill. The y values are decreasing down, 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 down when the x values are between 0 and infinity. And so 0 and infinity. When we switch from uphill to downhill, that's when we see a maximum. So your maximum, and now this is highlighted in yellow, so that'll go into your notes in that packet of notes that you have for this chapter. Maximum, minimum, and then this graph has the minimum value of 2 at x equals 0. I really like to write that as a point. So you could write it this way if you like, or you can write 0, 2 is a minimum. Or, sorry, a maximum.
Yep. That's everything we need to say. Now, what's confusing about this is when we're thinking about this, down here, our values are negative. Up here, our values for our y values are positive. We can have values that are negative, but still have the graph increasing. And so we have two kind of different things that we're talking about. One is positive or negative. The other is increasing or decreasing.
And then always fill in those habits of mind, and those will be in the workbook as well. The companion workbook has the habits of mind. And we actually want you to, can a function be increasing and negative? And that's what she was just talking about, on the same interval, and explain. So some explanation in your own words on that habits of mind. We want you to always actually fill those in.
Onward. I'll clear this board. So in this case, we've talked just briefly in the last video about the average rate of change, but now we're talking about over an interval. So what is the average rate of change of a function y equals f of x over the interval a comma b?
So,
Conway, what does a comma b mean?
so that's in a real general sense, like there's not even a graph or an equation or anything to go with this. But what you need to know is that average rate is the slope. Okay, so the slope between endpoints. Now remember, this is an interval, so this is an x value, and this is an x value. So typically what you do is you go to your function, whatever it is, find the y value that goes with a, find the y value that goes with b, and literally find the slope between them. That's what average value is. So, go ahead.
So like, there we go.
Okay. So the interval starts at a value of f of a. So again, you have the a value, that's the start of your interval. You're going to need to calculate usually the y value that goes with it. And then the b value, okay, here, calculate your b value, or your f of b, so your y value that goes with that. And then this says total change, so you would be looking for the y, the change in y. Okay, so when I think of change in y, sometimes we write it like that, like a delta y, if you remember this from literally from finding slope, that's what you do, change in y. Interval length is the change in x, so that's your run. You getting the like rise over run, we're thinking about slope. Average rate of change then is rise over run. So it's literally the slope between endpoints. Change it to 10. Oh. So it's this slope slope between ends is the average rate of change. That's worth writing down somewhere, because honestly, every single person can find slope if you're in Algebra 2, and that's all you have to do is find the slope. In fact, so this is actually a little peek into like calculus where we find the slope of curves at different places, so that's why they bring this up, is because they're getting you ready for pre-calc and calc.
And I want to just cycle back to like this diver and this real life example, because when that diver dove in, he wasn't cruising down at that constant rate of change that we see that line representing. He dove in, he like flopped around a little and then probably sped down. But that line is representing the average rate of change, or the slope, rise over run.
Was there circles at the top I should have clicked?
I do want to also point out
sorry.
that this is why you practice function notation. This is why you did that function worksheet, because when we're writing with this notation, don't let it foul you up. It's like Conway said, we're changing between
like y2 minus y1 over x2 minus x1. They're just like the good old slope that you've always known.
yep. And there is another one here.
Okay.
Arrow.
There we go.
In part B here, we're looking at what do the average rate of change over the interval. So again, they're giving us x values indicate about the functions.
I think it's helpful even just to write x like under these, so you know those are not points. They're x values, and those x values have a y value depending on their function.
And you can see here that -2 is this point right here where we're saying -2, comma 1. This 0 value is going to be our 0, comma 1. And so each one has a corresponding y value, but this bracket is really indicating that we're in an interval.
And then again, you're doing the slope between points. So here they've identified the x and y values for the first part. Here's the slopes that they found. So like y minus y, 1 minus 1. 0 minus -2. Careful with that. Minus a negative is positive. But it doesn't really matter because 0 over 2 is still 0. And it makes sense to me that this has a slope of 0 because I see that it's horizontal.
This one, I'm already predicting it's going to have a positive rate of change. And so when we go to g of x, we can see that same math that they've laid out for you, where they're taking away the y values and then the x values to find the slope in between the specified interval.
And you're pretty used to finding slope for straight lines, so it's kind of interesting when they curve it, how are you going to find the slope of a curved thing? Well, you don't. You connect the ends together. So the x value of 0, y value of 0, or sorry,
Scroll up
y
and
is on top.
draw that line in. So
Okay.
we're looking at the interval from,
For this one, 0, so
Oh,
it's,
yeah.
so for this one, it's -2 is the x value and 0 is the x value, so we're really finding the slope here of that line. So rise would be -4, because we're coming from 4 down to 0, and run would be 2, because we're coming from here to here. So 4 over 2, that's where -4 over 2 is -2. And when I connect those, you can see it. Yep, it's a downhill line with a slope of -2.
may I steal your pen? And we're really not finding this whole line, we're just finding it between those 2 points. Is that?
Well, it's not, it's just the slope, so. yeah.
Either way, it's gonna
Yeah.
be the same for the whole straight line, but they're asking for it for just that interval. The same thing is true then when we go to that next one, we're going from 0 to 3, and so, let me change colors here. We're going from here, that rate of change that continues all the way up, but really we're looking between here and here.
Yeah, so the slope, you're going rise over run, so it makes sense to me, even if I just could draw it on my picture, up 9 over 3. 9 over 3 is positive 3. So remember when you did this when you were in maybe 8th grade or something, when you were finding slope? Sometimes you did the subtracting, sometimes you just counted up and over and showed it on a graph. So you could do it either way, really, but we're just looking for slope between the 2 points.
And then that last one, from this interval, from this x value to this y value, even though it doesn't seem like a number that you have computed before, that would be the average change between those points.
Yep. So from 4, the value of 4 up to 9, you're going up 5. So 9 minus 4 is 5. And then you're going across, or rise and then run. Your run is 5 because it's from -2 over to 3.
Yep.
So you subtract and get 5 there. 5 over 5 is where we're getting 1 from. So slope between endpoints is just, they say it fancy as average rate of change, but it's not that hard. You can do it.
Just need some practice. And so in the try it now, here's your practice. So we've got this absolute value function, so we're already pre-thinking, we're like, okay, this is gonna have a v of some kind, either forward or backward. And so then you'll be looking between these two, just like Mrs. Conway said, this is an x value, this is an x value. So between these two x values, And so I would graph this out, I would draw it, I would either plot it out on Desmos, but looking at this, I'm not gonna be able to do it. I need to either graph it by hand or using Desmos so I can find the y values that correspond to the symbol.
And then plugging in y values into or plugging in x values into an absolute value, just know that the whole total doesn't always have to be positive. I mean, it will be in this case, but it wouldn't have to be. If I plug -2, so like this, if I plug -2 into the absolute value and add 2, it's -2, it's like absolute values are kind of like parentheses. You have to do that first. So -2 absolute valued is 2, because it's 2 units away from the origin, plus 2 equals 4. So right now, I could tell you that this point is -2, 4. So like that would kind of like be my start. And then my end point, I would plug 0 in for the absolute value, plus 2. The absolute value of 0 is 0, plus 2 is 2. So the point that this one produces would be 0, 2. And that's like my ending point. So I would find the slope between those two. Does that make sense?
Walk through it. Let's finish this example out. It'll be our last one in this video.
Okay, I'm just going to show you so the absolute value function typically looks like that v home centered at 0, 0. The plus 2 we know is going to scooch it up. So I already know what this graph's going to look like. Then I'm going to locate those two endpoints, -2, 4, and 0, 2, which is here. And I can about tell you what the slope is, but let's double check anyway. So this is, what did I say? -2, 4, and this is 0, 2. So for my rise over run, I'm going to be going down 2, over 2. So I bet my slope is -1, but I'd go ahead and do 4 take away 2, and -2 minus 0. You can do it in either order as long as you're consistent and your up and down is a point. So 0, 2, -2, 4. So 2 over -2 is -1. So the slope of this section, really the whole thing because it's a straight, the slope would be -1. So the average rate of change for that interval for this one.
So you're going to repeat this 2 more times and then make sure to check
Just
your work.
3 answers and show your work. And then if you just type anything into this box and hit check answer, it'll show you the correct answer. It won't show you if you're right or wrong. You have to decide that. If what you've got written matches that, then you had it right.
And remember to go back for my class over with color so that I can see the difference between what you were thinking first and then what the answer helped you kind of figure out.
Yeah, I think that's a good idea always. Just do it in pencil and then correct it in pen.
Excellent job making it to the end of this video. Hopefully it was helpful, and we'll come back with problem 1-2. That'll be our next problem, I believe.
Thanks.